I want to tell you something about how to write a compiler plugin and enhance the GDPR compliance of your code. At first, who am I? My name is Vincent de Haan. I work at CodeStar in the Netherlands. And I have been programming for some years, but before I got into programming, I studied law, and I also worked for a few years at the compliance department of a software development company. So probably when you may see that in the things I will be saying, because the problem that I will be explaining and that I have a solution for in this talk is a problem that actually existed when I was working at this compliance department. So it's a real world problem that we're going to solve using some tricks in the compiler. All right, well, I have two goals for today. First, I want to take a look inside the compiler, and second, I want to develop a nice compiler plugin to enhance GDPR compliance. But I think the first goal is the most important one, because what you see mostly is that there are people who are building the tools that we use, and you have the people who are using them. And those two groups are often quite separated. And the people who are just working at the business and using the compiler, they often find it scary to look inside the compiler, and they think it's very complicated and that they won't understand it. But I think that also, if you're just a user of the tool, it never hurts to look under the hood to see how it works. And you don't have to understand the whole compiler to make useful additions to it. And that's what I want to show today. And the example that I'm using for this is this GDPR use case, which is also very useful, I think. But I hope that the most important takeaway is that you learn that you can also, if you are not into the design of the compiler yourself, that you can sometimes look in the code of the compiler and do something useful with it. All right, let's first give a short introduction into the GDPR, the General Data Protection Regulation, which was enacted by the European Union a few years ago. It says a lot about data protection, but one of the articles that is particularly interesting here is Article 30, which says each controller shall maintain a record of processing activities under its responsibility. That record shall contain all of the following information, and then there's a whole list, but at least you should know the purposes of the processing and the categories of personal data that go along with it. And this is an article that is understood, that can be understood in two ways. Some people think, all right, well, I just have an overview of my data model. I know which fields of data I have in my database, and then I'm done. But it says processing activities, which means that it's not the data at rest which you are interested in, but the data in motion. So it's not enough to know that which data you have in storage, but also what to do with it. That is what you should have a record of. And I will give an example. For example, we have a banking application, and the bank knows a lot of things about its customers. So they have a database, and they have names, and they have addresses, and they have scans of identification documents, for example, passports. And the passport scan is a very interesting piece of data because it contains a picture of you, which conveys, for example, the color of your skin, and it conveys whether you're attractive or not. It's a very special kind of data. All right, now suppose that you are that you need to develop an application with which customers can apply for a loan. So we built a front-end application where the customer can enter the information about the loan, and we built another front-end application where the employee can see the loan application and approve it. And then we need to build a backend service. And the backend service will also get its data from this big database with all the existing customer data. And then someone thinks, well, maybe it's a good idea if the employee could also see the ID document that we have on file. But is it really a good idea? Because why is the identification document relevant to judge the application of a loan? Well, I don't think it is. Of course, it needs to be valid, but you can assume that if a customer is already a customer, that the identification document has been checked. And what you can see on it is, for example, what the person looks like. But that's not relevant when you decide to give him a loan or not. So so that's something that you may want to discuss with the business and with the legal department whether it should be there. But mostly this is not discussed, and it's just someone who is creating this feature who thinks, well, oh, all right, that's a good idea to put it there. So then what I thought, well, this decision to put this document, to give this document to the employee, that goes along with at least one line of code, which is something like this. So it's a repository and then the get ID documents method. And this is the point where some developer is writing this code and where he should wonder, well, is this really a good idea? And maybe I should discuss it with the compliance department. Well, so what I did when I was in the compliance department, I tried to instruct all the developers that they had to be really careful about the GDPR and that they had to know all the rules, and that whenever such a situation came up, they had to come to me and discuss. Well, this never worked because developers, they don't like to particularly to work with the law. That's why they became developers. So I wanted to design another approach where I got a notification whenever something like this came up. And that is when I thought of this new idea. I thought, well, let's use annotations. Yes. All right. So this is this may be a piece of code. We have a repository. The repository has several methods, and we have some feature code. And in the feature code, we use the methods defined by the repository. And my idea was as follows. Well, let's mark the repository methods that may indicate processing of data as such. And this is something we need to do only once. So once the compliance officer sits next to a senior developer, he puts the processing annotations in place, and then this will probably not change that much. So then it's good for a long time. And then when we are going to use this repository, which is done much more often, then we need to apply another annotation here where we can determine the purpose of this processing. And then we need to make a business rule which says, all right, whenever you use such a processing annotated method, then you need to use this processing instance method or annotation as well at the call site. So we have two rules. If a method invocation has a processing instance annotation, then print it, because that is the report that we want to send to the compliance department. And if an invocation of a method that is defined with a processing annotation does not have a processing instance annotation, then throw a compiler error. Well, this is the idea. And then the question became how to enforce these rules. And I thought of many things, but in the end, it turned out to be quite easily to be implemented as a compiler plugin. And that's something I will show you now. What I will show you is a bit of a simplified version of the compiler plugin. I have developed this a bit further now, so you can look it up on my GitHub. There's a whole project also with an SBT plugin, but I'm showing the simplified version because it's because the principles are the same and it's easier to read. All right, but before we can write a compiler plugin, we need to wonder, how does the compiler work? Well, the compiler works by creating abstract syntax trees from our code and transforming those to other abstract syntax trees. So how does this, what does this look like? Here we have a very simple line of code, and this line of code transforms to this tree. And we can recognize the code in the tree because here the main structure is the value definition. And we see here a val def with the x and then the rest of the expression. And here in this part of the expression, the main structure is the plus. And here we see an apply node with the plus method. And also we see the times method here. So it's quite easy to see how this tree relates to this part of the code. And all the code that we are writing, also when it's much more complicated than this, it will be transformed by the compiler to such a tree. And in the end, will also, and then the compiler will make transformations on this tree to, in the end up with a class file. And these transformations are done in multiple stages. And we can also ask the compiler which stages it has. And this can be done by this command. This command shows all the stages that the compiler takes processing the Scala code. So it starts with a parser, and in the end we have the JVM stage where we generate the JVM bytecode. And as you can see, there are quite a lot of stages. The nice thing is you don't have to understand all of them to make good use of this knowledge. Well, here we see it again. And what we are going to do is we are going to create an extra stage which does not transform anything, but it just performs some checks and create some additional output. And then always when we are writing a compiler plugin, the question becomes, where do we insert our plugin? And the rule is as early as possible, but not earlier. Why? Well, the earlier the better, because in the earlier stages the code looks much more familiar, so it's easier to work with. But if we do it too early, then the compiler hasn't prepared the tree enough for our purposes. So we need to wonder first, what is the purpose of the plugin, and then we can find out what stage is best. And in our case, what we need is we need to connect in some way the methods at the call sites to the definition of the method, because the processing annotation is created at the definition of the method, and the check we are going to do needs to be performed at the call site. So we need to have this data about which methods have been annotated and which not, needs to be transferred from the definition to the call site. And it would be very, very nice if the compiler would do this first, because then we don't have to do it ourselves. So how can we know this? Well, there is a nice way to look inside the compiler and to inspect the trees during compilation. We are using the browse flag, and then I am going to choose a stage which is the typer. This is this one, and well, I've done this before, so I already know that this is the right answer, but before I knew this, I had to try a few, and then a simple example Scala file. And then the compiler launches this curious user interface, which gives us an overview of the tree during this stage of compilation. So what we see here is that yes, we see the Scala code. Well, it's a bit more complicated than normally because it contains all these placeholders, and the compiler has already added some things that are implicit normally, but we can recognize some things that we already saw. And let's look at the call side of this repository.getName. Because here we see that we have annotated it with the processing instance annotation. And what we want to check now is, and this is necessary if we have this thing defined with a processing annotation. So the question is, do we have this information about the definition at this point? Well, then we are going to browse through the tree, and we are going to look what data we have available. So here it is still. Yes, here it is. And here we see the repository.getName. So this is the right node. And here we see that we have an annotation processing. So apparently in this stage, the compiler has already found out that this thing, that this identifier is related to a definition where the processing annotation was made. So this is very useful. So we are going to apply our plugin after the typer stage. Right. So before we can start writing our plugin, we need a skeleton for the plugin because we have some boilerplate. Well, we can easily download it from the website of the Scala compiler. So let's not do too much work there ourselves. And it looks like this. And there are a few things that we need to notice. First, we can define the name of the compiler plugin. We can give a description of it, and we can define the name of the compiler phase that we are going to introduce. Then we can define after which phase it needs to run. And as you can see, it's a list type, so we can run it multiple times if we want to, but it's not necessary in our case. So we have only one element, the typer. And then here the magic happens. We get a method we can override, which gives us a tree, and we can return another tree if we want to, if we actually want to transform something. But here we don't want to transform anything. We only want to perform some checks. So we will return the original tree when we're done. All right, well, let's get started. With the first task, if a method invocation has a processing instance annotation, print it. So that's the easiest thing. If we encounter a processing instance annotation, just generate some log line or something. Well, then we need to first know how to read these trees and how to interpret them. And well, it is documented on the internet, but it is not very easy to understand. So mostly it's easier to just play around with it. And fortunately, we can actually play around with the trees on the command line. So look what's happening here. I have this Q here in front of the string, and this is called a quasi-quote. And what it means is that this string isn't a string, but it needs to be interpreted like it is Scala code. So as you can see, we also get the type of a tree and not of a string. And then we can use this show raw method to print the full representation of the tree. So whenever you get a piece of Scala code and you want to know how the compiler would represent it, you can easily use this trick to see for yourself. So then we are going to catch the processing instance. And as we saw in the tree browser, in the user interface we saw before, we have to look for a typed node with an apply node in it. And then we find that we can extract 4 variables, of which one is this type tree, which is a bit mysterious, but it looks like we need to do something with it. Yes, this one. So what is this TPT variable? The type system says that we have to use it in some way, but we don't know what it is, in which format it encodes some information, but maybe it's useful. So let's just try to print it. So in one of my trials, I just printed this type tree and hoped that it would teach me something, and actually it did, because I got this structure and it contains my processing instance, and it also contains the purpose, and it contains the content of this purpose. So this is very useful information for the goal we are having. But it looks a bit strange, because this part looks like a case class structure, but then here we have this set original method. So then I had to do some guessing, because this is not documented at all. But if you guess, you get very far sometimes. So what I did, I just guessed that if set original with this payload is what it says, well, then maybe if I do just original, then I get the payload. And it turned out to be true. But then I had this complicated tree, and I wanted to get some things out of it. For example, this string. So I thought, well, I can use pattern matching to extract it. But as you can see, it becomes quite complicated, and I lost track of everything. So this was not the way to go. And then I found out that there's another much more elegant way to extract these kinds of trees. Because the quasi-quotes that I already showed you, they can not only create a tree, but they can also be used to extract trees. For example, if I have this tree, and then I perform this, then something magical happens. Because here, this is a variable. And what this does, it performs actually a pattern match, and it assigns the thing that has been matched to this variable A. So we define here A with a tree, which is this 2. So this can be used to extract trees in a very convenient way. Because here we see what we can do. We have this type tree. Well, this part is this we had to guess. This is not not a systematic way to determine how this had to be done, but this we just guessed. And then we are going to match it, and we can just write Scala code here. So we have an expression, then we have the processing instance annotation and the purpose, and because of this Q here, this line is able to extract the tree. So then we can just print our log line, and we're done with the first goal. Well, let's note that we also are creating a set of all these applies which have been annotated, and it will be clear later why we are doing this, but I noted already here. And then we also perform the transform of the superclass to make sure that nothing breaks within the compiler. All right, then the next step is a bit more complicated. If an invocation of a method that is defined with a processing annotation does not have a processing instance annotation, throw a compiler error. So if we have a processing at the definition side and we don't have a processing instance at the call side, then we throw an error. All right, and then let's go back for a moment to the tree browser. To see what this looks like. So it means that whenever we have an apply here, which has processing, that then the node directly above it needs to be a typed node with a processing instance on it. And because it needs to be the node above it, and we don't have a way in the tree to go up in the tree, we needed to cache all the nodes that we already found with the processing instance so that we can query them later. So here is what we are going to do. We are going to look for all the apply nodes that we need to inspect. And then we are first going to filter all the unannotated processings, because the annotated processings we already found in the previous step, and we store them in this set. So if we have a processing that is not annotated yet by a processing instance method or annotation, but at the same time it has a processing annotation at the definition, then we have a problem. Now you can see here that I have a not so nice way of checking for the processing annotation. This can be done in a more elegant way, but then it's a bit more work, and this works also most of the times. So for this prototype I use this one, but if you look at GitHub, then you see that I solved this in a bit more elegant way. And if this is the case, well, then we print an error. Well, this is just text which we print to the terminal, but we can also actually report the error to the compiler, and then the compiler will handle it like any other compilation error that it knows. So then the compilation process stops, and the compiler says, well, we had an error, and it also shows exactly the position in the code where the error occurred. So now we also have implemented rule number 2. So within less than 100 lines of code, we have created a plugin that interacts with the Scala compiler and that actually gives us some business value. So I think that's quite interesting. And now I will demonstrate how it all works. So I prepared some Scala code, and note that it will not compile because here we have a line which should yield a compiler error, because we have this getName method. GetName has the processing annotation, but it does not have a processing instance annotation on it. So it should not compile. Well, let's look. Well, I need to add the plugin to the compiler using this flag. And then if I compile it, then it says, well, one error found, unannotated data processing found, and it gives us the exact location. So it works like we want to. Well, let's change it then. And then it works perfectly, and it reports that it has found data processing on line 15 with the purpose customer support. Well, we can send this report over to the compliance department. If they have any questions, then they can come and ask, well, all right, but why do you need a name for customer support? Well, that's quite logical, but if it would have been something different, then they could ask a question. All right, well, that was on creating a compiler plugin. There's of course more work to do because we want to maybe output this to a file. And we also want to create an SBT plugin, because what I showed you now is how to compile an individual Scala file, but mostly we will have projects which contains hundreds of files. And then we also have to write an SBT plugin which drives the Scala compiler plugin. Well, this is something I already did. You can see it on my GitHub. But it's not very interesting. It's quite straightforward. We can also think about the bigger picture, because what we try to solve here is a more fundamental problem in documentation. As developers, we have to write a lot of documentation for ourselves, for our customers, for the legal team, for other teams, and the problem I always see is that it's hard to keep this documentation up to date, because you change the code, but you always forget to update the documentation because it's not very fun to do, or it's difficult, or you even forgot that you had some documentation, in particular if it was documentation that was written for someone else. So I think in an ideal world, you would extract as much documentation as possible from the code. And sometimes this can be done with products that are already there, like JavaDoc, but sometimes you also need to create custom tools to extract the documentation. And I think this is a good example of this, and we can use this in this and other things like it in a lot more contexts. All right, well then, a final remark is that this works in Scala 2. It works in Scala 2.13.1. In 2.13.0 it doesn't work because the tree browser I showed you has a bug in 2.13.0. So if you are trying this at home, well, be aware of that. Plugins work in 2.13.0, by the way. But the question is, of course, will this work in Scala 3 as well? Well, it will work. There is plugin support in Scala 3. Of course, we will have to change the internals of the plugin because the compiler works differently. But there is support for additions which will be made by third parties. So I'm hopeful that we can continue this approach later. Well, I hope you enjoyed my talk so far. And if you have any questions, I will be available on Slack later and also this week. You can see the project on my GitHub. And I hope you have a great day. Thank you very much.
May I ask a question?
Sure.
Okay. The question is, Maybe I just missed when I was watching the presentation. Thank you for it, actually. What are the real use cases for GDPR compliance?
Well, the problem is that the GDPR forces companies to have a record of their processing, so a document with all the processings that they do on their data. And it's quite hard for people in the legal department who make this record to be complete and to know all the processings that are happening in a company. So then they go around and ask everyone, well, do you process data? Do you process data? Tell me which processings you have. And in practice, it always turns out that they are incomplete, because people say, yeah, well, I process this data and this data and this data, but they also forget that they process data in other ways as well. And what I'm trying to do here is just extract all the processings from the code so that you can be complete by design.
So it's just about revealing where we processing essential data. Yes.
Yes.
Yeah. Okay.
And the main purpose is to be in compliance with the law, and the authorities require.
But as far as I know, we have different layers, different levels of information sensitivity. Personal information, depersonalization information. Do you support such levels?
Yes. Well, in the project that I've been working on, I support different kinds of information, but for this example, I try to keep it simple. But it is, of course, possible to customize the types of information that you are interested in.
Okay, thank you very much. Thank you.
You're welcome.
Hi, thanks for your talk. And I have a question. Is there a way to get errors about missing annotations as you type your code, so before compiling?
Well, in that case, you would have to implement the plugin in the presentation compiler as well, and I don't know if that is possible, but it's an interesting question.
Okay, thanks.
Yes, well, there was a question from Vladimir about pseudonymization and anonymization of processed data. So I think maybe I should clear something up about my talk, because what my talk is about how to document the data processing activities that we are doing, but it's about documenting them at compile time. So it's not about handling the specific data points that are running through the code when it's running. So of course, and what I suggested to Vladimir as well is that what you can do if you want to do something with pseudonymization is that you use different data types for your pseudonyms and for your complete data. And that way you can always make sure that the compiler enforces you to use the pseudonyms where you need the pseudonyms and the complete data where you need complete data. But that's not within the scope of my talk, so it was just a suggestion.
I have a question which is not related to your talk, but you work at Ordina, right?
Yes.
Does Ordina adopt Scala a lot, or is it just you, or how does that reflect?
Well, Ordina is quite a large company with 3,000 employees, and we deliver all kinds of IT-related services. And within Ordina, we have a smaller team, which is CodeStar, which consists of 20 or so employees, and those focus mainly on Scala.
So my interest is in how does your team of 20 people adopt new people into Scala, and because Scala is a very versatile language and you can do so many things in so many different ways. do you have a code style, or how do you maintain that level of maintainable Scala code?
Yes, well, we are a contracting company, so we work. We don't have our own code bases that we need to maintain. We maintain the code base of our customers, and well, we hire, of course, good people who are willing to learn a lot and who are very smart. And I think we hire above averagely smart people. And we do what we do is we work for 4 days a week at the client, and for 1 day a week we work at the office. And sometimes we work for the client at the office, and sometimes we also have research and development days where we interact with each other and share knowledge. And we also have lunch sessions where we share knowledge, so that the knowledge that we acquire at the customer is also shared in the team. So I think that's the way we do it, but mainly we hire people who are already familiar with Scala. So they it's not that we have a training program for it.
Okay, thank you.
I also had a topic which is maybe I'm curious to hear about from the others, because my talk is also about a broader concept, a broader problem, that we always need to write documentation for all kinds of stakeholders, and the different stakeholders want different level of detail of documentation, and we need to keep this documentation synchronized with the code. And this, in many companies I've seen, is a problem. So I would like to know, do the others have a suggestion how to handle this problem?
Interested, are you thinking about tools which just illustrate and wrote a text in Coda? Maybe we remember literate programming. Yes, and but practically we have inverted literate programming when we have Coda and near Coda we have comments.
Mm-hmm.
All what we do is publish comments and trying to check that that these comments are correct. So we have something like big comment, yes, usually in packaging, which come through compiler after some stripping and check it that it works.
Yes, well, this is an approach that you used to see a lot, but does it also work for the documentation that you need to produce for the business?
But I don't think that business need such level of digitalization. Maybe such low things, no, as you work, yes, when law is needed, then we need trace. But for decisions, we need high level view, which is more different, which is not need digitalization.
So I work for Alliander, and we have some experience with the C4 model. The benefit of that is that it has multiple levels, because not every level is appropriate for each stakeholder. But it is a hard time synchronizing the code with those models as well. So it has a kind of knack to update those models, and not everybody does that. So I think that communicating decisions overall is a hard thing, and that we haven't found a very good way of capturing all those decisions and communicating them. So I'm interested in the answer to that question as well.
Yes, well, I myself try to, or I'm looking for ways to extract as much documentation from the code directly, but for the technical documentation, this is often quite easy, but for the higher level documentation, this is more challenging sometimes.
Maybe it is a signal that we need more high level, that our code is too low level.
Yeah, well, I think that could certainly be true.
Sorry, guys, I missed the beginning. We are talking about documentation, technical or of any kind.
Well, basically documentation of any kind, because we need often to create documentation of different levels of the same code.
Ah, I guess. Okay, let's see.
Yeah, and I do think that a lot of the decisions aren't on code level. So like the reason that you do something sometimes dependent on the politics within a company, and that decision process, which should be part of the architecture, is at least at my company not well documented. For example, why to choose for some service provider over another, basically not well documented. So I don't think it's only code related documentation that needs to be shared, but also these higher level driving forces that provide context in your project aren't well documented, at least in my experience.
Then you more like talking about knowledge transfer inside the company, yes, not the documentation for third parties outside.
Well, I think that's another subject as well. Like, how do you transfer knowledge from one person or one team to the other? But only for a single project, at least, having a trace of which decisions were made with which insights at the moment almost always ends up being folklore. Like,
yeah,
you can ask about it, and people can tell you, oh yeah, this is because of this reason, and we had to. The lead developer had made this decision, but you can read a document and get a sense of the decisions that were made, which is a shame because those
you know, I faced almost the same problem, and I've tried to create a full documentation in my company in a situation where we have a lot of teams, a lot of separate teams, and I tried to create a common context for all the teams. And the lesson I learned is that it is not always necessary because what kind of documentation is good? The good documentation should solve the problem. It don't have to be complete, it don't have to be full, it have to just solve the problem. So as far as I carried out from those situation, good documentation is always short. It should be as small as possible, because if you create a big documentation, it will become obsolete very fast. So good documentation as short as a message in Slack. It's the best kind of documentation to be short. Second lesson is that you don't have to put a lot of information. It's way more convenient to put a context of the people and their roles. For instance, you have some service, nobody knows it even exists. You put it to some catalog and say, we have such a service, that is business value, 1 or 2 sentences, and there's 2 people in charge of it in such roles. And it looks like it could solve 80% of questions you might have, because every time I need some information, I have a different question. It is way more easier to ask exact person what was happening, why you do such a decision. And if they answer you with a Slack message, you just can copy paste this to your documentation. Something similar I heard works well when companies create their internal Stack Overflow, where you can answer a question and people just answer it and it works fine. So maybe 3 lessons. It should be short, it should hold the context of the people, and maybe some kind of Stack Overflow. It is a mistake to treat internal knowledge transfer with documentation for a third party. For a third party, documentation is like a product. It should be big, complete, nice, neat, etc., 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 with tech writer, a lot of stuff. But for internal knowledge transfer, it is not necessary. So short, concise, and it will work. Because if Slack communication works, that means that even Slack documentation will work too. That's how I see it. That's my experience.
Yeah, interesting to make this clear distinction between internal and external documentation. I think it's spot on.
Yes, it is the speed because we can broker many things internally usually, and we can broker fast. I remember one project where we completely changed internal IP very quickly, and it was impossible without. It was impossible to do this with documentation. So it was not how documentation was competitive advantage.
By the way, my mistake was I was trying to create full and complete documentation, and what happened? Nobody read it. Everyone was just trying to ask, just tell me, I won't read all this stuff because I'm not a tech writer and it's not a product. And inside a company, you don't have a lot of consumers of your documentations. So it may be way more easier just to answer in Slack with a message in Slack, and it will be enough. Because internal knowledge transfer is not a product.
Maybe it depends from size of company, because for example, when we work with documentation, when our team was 3 or 4 people, I remember, yes, with 20 people, it's quite different.
You know, I never heard about company where teams more like 20 people, but knowledge sharing is required inside a team or between neighbor teams. You don't have to write documentation for all the company at once. It's more like a product already, but it's really a rare case. It's for me. The only example I saw, it's Uber and Netflix. Or for instance, Netflix. Guys from Netflix talk about their microservices infrastructure. They have a lot of microservices. They don't have a central point of management of this stuff. What they are doing, they are creating in central point in DNS. They announce their microservice and just trying to sell it to everyone who wants that use. And all the documentation you put in your microservice is that people need to know just to use your microservice. And it's a huge crowd of people, microservices, they're trying to communicate, but they do not have single need documentation hierarchy because it just doesn't work.
So they have API description, I guess.
Yes, API description and catalog of microservices, and each team trying to sell their microservice to each other. And that's how they measure success of your team. If your microservice is not used by no one, you won't achieve any promotion, never. But if you receive a lot of API calls, you might be promoted because you are doing something.
Good idea. And what do you see about approach living without documentation?
You know, a lot of people live without documentation and do it fine. It's the best evidence that it's not required, actually. If you can do your job without it, that it's okay. You might have some short need documentation, not even documentation, like maybe a welcome landing page on your team, when you can tell other teams what they're doing, who are in your team, and what are their roles. And it's enough to handle the work.
But for this, I guess that any change in team will be critical, and it's also.
Yes, but who cares? It's critical now without documentation. You know, documentation is not a panacea as far as I believe in it. Even if you create full, exact, detailed documentation, it always costs you money. it becomes obsolete very fast. It requires a lot of money to maintain. It's not always worth of value it brings. So you have to find a balance between value and cost. And in my opinion, the best value cost balance is business value to sentences, who in charge of this stuff, their roles, and maybe a list of Slack chats where they communicate. And it solves 80% of the problems. Just you know what to do. It doesn't solve the bus factor, but let's be fair, we are not riding a bus in these times. So
yeah, well, for internal communication, I totally agree. But I hope that with my plugin approach, that we can also make it easier and, as you say, less costly to create external documentation, because that is in fact what
XML is completely different stuff,
yeah.
because it's a product. You sell documentation as your product, so you have to have a tech writer and special bunch of team to do this.
Other questions. Are you playing with internals of Dotty?
No, not yet. I've not yet looked at it, but I know that it will be possible. So I will do this later this year.
Because they have separate compiler and macro interfaces. It's something different, and internals are more cleaner than Scala 2.
Looking forward to it, but I've not started yet.
Are you following for development of other languages than Scala?
Yes. Well, we have also at the company experimented a bit with Kotlin, but I myself is working mostly in Scala and Java.
Okay, and what Scala need to adopt from other languages?
Yeah, that's a good question. Well, I think it's what I really like is to have to make optimal use of the type system. So to do something with dependent types, for example. And I don't know if that's already adopted in Scala 3, but otherwise there are some libraries who are working with it, but it would be good to have native support for dependent types.
Any news from GDPR world? Something fresh, something special?
Well, the only thing I know is that in the Netherlands at the moment we are creating all kinds of apps to track who has had corona and who has not, and there is a lot of discussion about whether this is privacy compliant and also. So I think the GDPR is at the moment highly debated, but not by me. So I'm not an expert on that.
Okay, thank you.